2a, in the shuttling ball experiment, explain why the ball shuttles faster if the potential difference between the plates is increased or the plates are brought closer together. So, let's go back across. And first off, we need to make sure we're clear what the shuttling ball experiment actually is. So, what we've got is one plate that is made positive, and that's connected around to a power supply, positive end of the power supply, and there's another plate that's negative, so it connects on the negative end of the power supply. Now, what there is in between is an insulator, and it has to be insulated ball. What will happen to the ball is it'll move. For example, if at the moment if it's negatively charged, it'll be attracted to this wall. Then what will happen is the electrons will jump off. Now, more electrons will jump off because they're attracted to the positive. So the ball will then end up being positively charged, be repelled. So it'll be repelled and swing back across. It'll hit the negative plate. The negative plate then is going to provide it with a lot of electrons, and it'll actually get more than neutral. It'll end up negatively charged and swing back across. So you can see this ball is going to swing back and forth between the two. If you wanted to, what you could put on here is a microammeter and actually measure the current going actually across because of it swinging back and forth. So the question we're asked then is, what would happen, or explain why it would go faster if we had a greater potential difference between the plates. So let's work through. So we've got increased PD across the plates. Now, this could be achieved by shoving more electrons on here, taking more electrons off of here. So basically just having an increased voltage across the power supply would actually achieve that. And what it'll actually do is mean you've got a stronger electrical field. So it will increase the strength of the electrical field between the plates. So I'll increase the electrical field. Now, if we think about what does that actually mean? Well, if I've got a given charge on here, so for the same charge on the sphere, for the same charge on the sphere, there will be a greater force. On the sphere. And we know that because F is equal to EQ. We've said the electrical field strength increases, the charge stays the same, therefore the force is actually still going to increase. Now, that means we have greater force, so greater acceleration of the ball back and forth. Second thing that's actually going to happen is, if there's a greater potential difference between the two, it's like having extra charges on here, there'll be more charge on the sphere each time it goes back and forth. If you can imagine, if this is very much more positive, it will drag more electrons off, making this equally positive. So we can say the charge on the sphere will increase. Now, again, so there's going to be a greater force because F is equal to EQ, and we've increased Q. So therefore, F must be increases, so we'd have a greater acceleration. Now, the greater acceleration will mean greater speed on the ball moving back and forth, and a greater or a smaller time between these collisions, back and forth with either side of it. Okay. Now the second part of the question asked us, what would happen, or explain what would happen, or why it would go faster if your plates were brought close together. Now, if the plates were brought closer together, the strength of the field will increase. And it will increase because we know the electrical field strength between two parallel plates is the potential difference divided by the distance. So I've reduced the distance, therefore I've increased the electrical field strength. Now if I've increased the electrical field strength, you can actually see that again the force is going to increase. So from that perspective, that means the force is going to increase. Force will increase. So force will increase because we know F is equal to EQ. We've increased E, therefore we've increased F. So force will increase, so acceleration will increase. So acceleration is actually going to increase. Now the second thing we've got, in this case, the actual potential differences on them haven't changed. The charge I still expect to be the same, so that's not going to make any difference. But now we've actually got a smaller distance, a smaller separation. So separation will be smaller. So the separation is smaller. So less distance. So again, as well as having increased acceleration and increased speed, we're going to have less distance to travel. So the shuttles themselves will be faster. Now I'm not entirely sure what this question wants in terms of speed, whether it's talking about speed or whether it's talking about the time between the two. So I've mentioned both. Anyway, those have been my answers. Thank you very much.